2.4 is what's called the rational root theorem today. I'm actually not going to make you write the definition for the rational root theorem. I'm going to kind of explain it as we do a problem. So that way you could obviously open your book right now and copy down the rational root theorem, but you're going to look at it and be like, what's P, what's Q, what are they talking about? So just listen to what I'm doing in this first problem and it should make sense. So you are going to list all the possible rational roots and then determine all the zeros for 6x cubed plus 11 squared minus 3x minus 2 equals 0. First things first, do you even know what the word rational means? Or do you know how about a ratio is? Yes.
I think a rational number is something.
All the possible roots, you have to list all the P's and the Q's, which is what they give it the title if you read again the directions or the definition. So in this polynomial, this last number is your P and this front number is your Q. Okay? And according to the rational root theorem, P over Q is a rational root. So what does that mean? Well, what it means is you have to do just a tiny bit of work. This is actually probably the easiest question right here. You have to list all the factors of P and of Q. So we'll talk about this together right now. Let's list all the factors of P and then list all the factors of Q. So what would be all the possible numbers that make -2? -2 and 1 or -1 and 2. So the way that we write it is we write plus or minus 1 and plus or minus 2. Those are all the possible ways to make -2. Do you agree to that? You do the same thing for the front number, which we call Q. What are all the possible factors of 6? 6 and 1, or 2 and 3. Or, here's the other thing, it could have been -2, -3, or -1, -6. So we do the same thing. We just put plus or minus 1, plus or minus 2, plus or minus 3, and plus or minus 6. To write all the possible roots are all the P's over all the Q's, and writing them all out as fractions. So you would write this. So if I took my first P and I put it over my first Q, 1 over 1 would be just 1. Would you agree? So plus or minus 1 is a possible root. And I keep doing that. Now I put my first P over my second Q. How do I write that as a fraction? Plus or minus 1/2 P over Q. Or plus or minus 1 over 3. Or plus or minus 1 over 6. And then you do it with the 2 now. Plus or minus 2 over 1. Plus or minus 2 over 2. Plus or minus 2 over 3. And then plus or minus 2 over 6. But wait a second. Don't I have some doubles in here?
Yes.
What are my doubles?
2 6 and 1/3.
2 6 is the same as 1/3, so cross one of them out. Just cross off the 2 6. And then isn't 2 over 2 the same as 1? Okay. So what you've just made is what we call all the possible rational roots. These are all the possible 2 over 1. I could have just kept 2. I just wrote it like that. This right here is the first part of your homework tonight. This is like question 2 through 4. This is all you have to do. You just have to write out all the possible rational roots, not the imaginaries, just the rational ones. It's one of these, or it could be 2 of these, or whatever. Okay, now, back in Mrs. Setta's day, in order to determine all your zeros now, you would have to take each one of these roots and synthetically divide it into here and find out which one is a 0. 2, 4, 6, 8, 10, 12. I would have 12 synthetic division problems into here. That's the way my teacher did it. And it was funny because Mr. Belt came down to me and he's like, so you're not making them do all the 12? And I'm like, nah, do you want them to do all the 12? He's like, I was like, did you have to do all the 12? He's like, yeah. I'm like, we know we had to do all of these synthetic divisions by hand. But I'm going to be nice to you. I'm going to be kind. I'm going to let you use technology because there's a reason for it. But I want you to understand, if you weren't allowed to use this on the SATs or something, that you would have to then start synthetically dividing to find all those zeros. And what are we looking for? We're looking for a remainder of what? Zero. Looking for a remainder of 0. So here's the first part of the question. We found all the possible roots. Now, all the possible rational roots. Now we're going to determine all the zeros. So here's your second step to determine all the zeros. Use a calculator to find a 0. Use a calculator. So go to my calculator. Go to your y equals, of course my calculator's dead, 0. I found 1 0. You could keep scrolling, but I believe that's my only 0. What's my only 0 right now? Hopefully you have it at yours. -2. Can I keep this, David?
Okay.
Thanks. All right, so we went to our calculator, and again, you are so lucky you have no idea how much time I'm saving you right now. You ask Mr. Belk, you ask Ms. Davis. We would have to synthetically divide. And for me, that means I would start at 1 and -1 and 1/2 and 1. I would never get to this 0 until all the way over here. I'd already be at the end of my problem by the time I found my 0. I was like, oh. So this actually means, do you all agree the factor is x plus 2? Agreed, right? -2. Okay. So now once you find a 0, you are now going to do step number 3, which is to synthetically divide. Okay, you do have to do a little synthetic division here. Until you get a quadratic. And why a quadratic? Well, that's why I'm making you do the IXL section C, because you should all know how to factor a quadratic. Y'all agree there, right? That was just me doing synthetic division fast. This is what you did last night for homework. Okay, now, question. 6 is now the coefficient of x to what power? Squared. X minus 1. This can be factored. This can be factored into, well, let's see. If you don't know how to factor, you better know how to factor. 6 times -1 is -6. What two numbers multiply to -6 but add to -1? So -3, +2. But because it has a 6, you have to do the whole bottoms up thing. So this reduces to x minus 1/2, agreed? But you could put a 1 here and then put a 2 there. This reduces to a 1/3, so I can call it 3x plus 1. But then wait, what you divided by is also a factor. -2 is actually x plus 2. So if I'm answering the question, I said, okay, what are all my zeros now? What are my zeros here? -2, 1/2, and -2, 1/2, and -1/3. That is what all the possible, those are all the answers right there. This is a degree 3 polynomial. So I have all my answers here. So here's again what you would, again, this is what you're gonna do. Tonight's homework, you're gonna list all your P's over Q, okay? Then in order to find all the remaining zeros, the extra ones that we didn't know exist, you take a 0 from your calculator and you just start synthetically dividing until it gets down to a quadratic. That's really boils down to. I mean, y'all, you can factor any high level degree polynomial now because of this, okay? So that's our first example. Let's try another one. This one's even funner. Right? All right, so again, if you weren't allowed a calculator, do you know what you would have to do first? You'd have to list all your P's and Q's. And let me tell you how many P's there are. Do you know how many factors of 24 there are? 1, 24, 2, 12, 3, 8, 4, 6. And then you'd have to list them all over your Q, which happens to be 1. So it's not too bad, but that's a lot of division still. Agreed? I'm skipping that step and I'm making you go to the first step, which is use a calculator to find as many zeros as you can. So in your calculator, you're going to go to your y equals and you're going to type in that. Be careful how you type it in because that's probably part of your problem. 3. Now, what does this mean? Well, that means they could have fractions. It means they could have i's. How many are here right here? How many zeros do we have? 3. But how many zeros are we needing to find total? 5. That means you have to tell me one of these could be a double root, meaning it could be divided by another -3, or there could be i's. So we're going to find all of those right now. And here's how we do it. Woo! We've got 3. That's actually a lifesaver right there when you get 3. So now you're going to do your synthetic division. And you're going to do synthetic division by every single one of them. And here's what I mean. So I just start with the top one, -3, and I'm going to synthetically divide it into my main polynomial, which is 1, 1, -13, -23, -14, -24. 0. Do you all agree? Okay. Tell me, here's my question. This is now a polynomial of x to what power now? The 4th. Okay. So what does that mean? Well, you want to keep depressing this. So now, instead of dividing by -3, I'm now going to divide by the next one, -2, into this one. So I'm going to take -2 into the 1, -2, -7, -2, and -8. And it should still work because it's still a factor of the original. So I do the decompression again. And I end up getting 1, -4, 1, -4, 0. This is now a polynomial of degree 3. Still not there. I want to get it down to a quadratic because quadratics I know how to do really well. So this is degree 3. Well, good news, we still have another 0 to divide by. 4. So now I'm going to take, again, don't go back to the original. Go back to this right here, your answer. 1, -4, 1, -4. 0, 0, 1, 4, 0. This is now a polynomial of degree 2. Do you agree? Okay, now what does this mean? Again, go back to the directions. They said, write this as a product of irreducible factors. All that means is write it in a factored way. Well, here's the factored way. This factor right here is x squared plus 1, right? Can that be reduced anymore? No. If it was x squared minus 1, it could. But then what you divided by could also be written as a factor. How do you write that? X minus 4. And then what you divided by before that could also be written as a factor. X plus 2. And even further up, we still divided by -3, which is x plus 3. Guys, this right here is the factored form of that polynomial. You just factored it all the way down until it can't be factored anymore. This is how you do any factoring polynomial. Like when you get lost, find a 0. Find a 0 and you can factor. Now here's my question though. The answer to the second part of this, list all the zeros, okay? So what would all the x's equal then? This is easy. So it's going to be -3, -2, 4. What is this one?
1.
No.
I.
Yes. Yes. X squared plus 1 equals 0 means that x squared equals -1. Take a square root. And what am I trying to keep going off in your head here? Plus or minus I. There's your 5 roots. 1, 2, 3, 4, 5. Those are all your roots, all the possible ones. You could do this for anything if you can find a 0. This is huge news when we find out about the rational root theorem. What? All right, I got one more. Are you not loving this? I know. I know. It's our last one. This one, so much fun. We are going to write a polynomial, and I should probably say a polynomial of least degree. I just didn't want to. But that's really what you're finding. Write a polynomial of least degree with zeros that are -5, 3, and 4 plus I. We've actually done this before, okay? We have. But I never gave you that one that's complicated. But now I am, because it's fun. First things first, 4 plus I, what's missing?
Minus.
Right, because every I has a conjugate. Don't forget about Mr. Conjugate, okay? All right, so that means, if you remember a couple lessons ago, that if you have 1, 2, 3, 4 roots, you're going to put 1, 2, 3, 4 parentheses. You're going to write x minus x minus x minus x minus. And in here, you're going to put the roots, just like we did on the quiz. So this would be obviously minus a -5, which is +5. Minus 3. Be careful here, though. You are minusing 4 plus I, which really is what? What do you have to do with that negative? You have to distribute. Yeah, -4 minus I, right? I distribute. Then what would this one be? -4 plus I, okay? And now you have to FOIL. If you don't like this, y'all better talk to the calculus students because that's all they're doing right now is foiling. And they're good at it. This right here is pretty easy to FOIL. I'll even give it to you. X squared plus 2x minus 15. But this one is really fun. Let's go. I'll help you because I know you're going to challenge with a triple and a triple. The way that I do triples and triples is, and I want to show you how I do it because I keep a system to how I'm doing it. You always do the first term, and I work backwards. I do x to the x, x to the -4, x to the I, and I write it down. X times x is x squared, x times -4 is -4x, x times -I is -ix. Do you all agree there? Okay. Then I do the same with the -4 in the middle, and I do that to each one. But watch how I place these. -4 times x is what? I'm going to put it under here. There's a reason why, because I'm going to combine them in a minute. -4 times -4 is positive 16. Well, I don't have any number all by itself, so I'm just going to write positive 16 out here on the side. And then -4 times -I is positive 4i, not to be put with an ix, but positive 4i. And then I'm going to do the I to everything, that last one. I to x, I to -4, I to -I. I to x would be what? Which is positive, so I'm going to put it under this column. I to -4 is -4i, so I'm going to put that under here. And then I to -I, what is that? Negative I squared, which is positive 1, right? Because I squared is -1, so negative of a -1 is positive 1. So I'm actually going to cross that off and write positive 1 right there. What I've just done is I've kind of helped myself make a column here, 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 and here. Notice what's happening though. Do you notice how the i's cancel out? They should. If you did it right, your i's should go away because they're conjugates. So you have x squared, you have -8x, and you have 17 as a trinomial that's multiplying this trinomial. But you're not done because you haven't found it in least degree. So keep foiling. Foil one more time. That is the polynomial. You got it. Look up here when you get yours. Of least degree that has zeros at -5, 3, at 4 plus I, and at 4 minus I. And that's how we do it now. Y'all know a lot. You can factor anything. You can FOIL anything. You're amazing.